Hey, Vsauce, Robert here. Go and take a look outside. You'll probably notice that your clouds aren't brown. That's not the case in South Asia. As a result of wood fire.
Hey, Vsauce, Robert here. Go and take a look outside. You'll probably notice that the clouds aren't brown. Well, that's not the case in South Asia, where clouds of soot and toxic chemicals cover areas the size of the United States. How does this happen, and how do these clouds make their way to the US of A? That's through air pollution and the use of fossil fuels by Chinese industries. Oftentimes, as many as 77% of the soot and 33% of the toxic mercury found in Los Angeles air comes from Chinese businesses. We have to stop asking ourselves where this problem started and start asking ourselves where this problem ends. And as always, thanks for watching.
(18.1) is what is the nature of our atmosphere. So the two innermost layers of our atmosphere are the troposphere, which supports life, and the stratosphere, which is the ozone layer. And our atmosphere is divided into spherical layers that are defined mostly by temperature differences. Two important atmospheric variables are density and atmospheric pressure. Density is the number of gas molecules per unit of air, and it varies throughout the atmosphere. Air at sea level has higher density than air on higher altitudes, such as high mountains. And atmospheric pressure is the force or mass per unit area of a column of air, and it decreases with altitude. 75% to 80% of Earth's air mass is found in the troposphere, which is closest to our Earth's surface. 99% of volume of air consists of nitrogen and oxygen. The nitrogen is 78% and oxygen is 21%. And the remainder of the air is water vapor, argon, carbon dioxide, and dust or soot particles, as well as methane, ozone, and nitrous oxide. Rising and falling air currents, winds, and concentrations of greenhouse gases play major roles in short-term weather and long-term climate. 18.2 is what are the major outdoor air pollution problems. So pollutants mix in the air to form industrial smog or photochemical smog. So industrial smog is caused mostly by emissions from burning coal, and photochemical smog is caused by emissions from motor vehicles, power plants, or industrial facilities. The definition of air pollution is the presence of chemicals in our atmosphere in high enough concentrations that it will cause harm to ecosystems, organisms, or even alter our climate. And air pollution can come from natural sources or human sources. So natural sources would be things like dust, pollutants from volcanic eruptions or wildfires. And then human sources would be burning fossil fuels in industrial facilities and emissions from motor vehicles and anything that falls into that category. Air pollutants can be classified into primary pollutants and secondary pollutants. So primary pollutants are chemicals or substances that are emitted directly into the air from human activities or natural processes. And then secondary pollutants are formed when primary pollutants react with one another. No place on Earth is not affected by air pollution because of prevailing winds, which spread air pollutants all over the Earth's surface, which has caused more than 1.1 billion people who live in urban areas to have unhealthy outdoor air, which can cause lung problems and other health issues. So, major outdoor air pollutants. The chapter talks about 6. The first is carbon oxides. So, carbon monoxide and carbon dioxide fall into this category. Carbon monoxide is a odorless, colorless, and very toxic gas that forms during the incomplete combustion of carbon-containing materials. And carbon monoxide can be emitted from motor vehicle exhaust, the burning of forests, smokestacks of fossil fuel burning industries, tobacco smoke, open fires, and even in some cases, ineffective stoves. And with long-term exposure, carbon monoxide poisoning can result, as well as heart attacks and lung diseases. Carbon dioxide is also a colorless and odorless gas, but there is more of it in our atmosphere. 93% of carbon dioxide in the atmosphere is from the natural carbon cycle, and the rest comes from human activities, primarily burning fossil fuels. And as we all know, there's growing scientific evidence that increasing levels of carbon dioxide in the atmosphere is being caused by human activities and is contributing to the warming of the atmosphere and projected climate change. And this evidence says that the carbon dioxide is being added to our atmosphere much, much faster than the natural carbon cycle can remove it from our atmosphere. The next major air pollutant is nitrogen oxides and nitric acid. So nitric oxide forms when nitrogen and oxygen gas react under high combustion temperatures in car engines and industrial plants. Nitric oxide reacts in the air with nitrogen dioxide, and then nitrogen dioxide reacts with water vapor to form nitric acid and nitrate salts, which are both components of harmful acid deposition, which will be talked about later. Nitric oxide and nitrogen dioxide both play roles in the formation of photochemical smog. And that nitrous oxide is a greenhouse gas, which can be emitted from fertilizers, animal waste, and also produced from the burning of fossil fuels. At high enough levels, nitrogen oxides can cause irritation to the eyes, nose, throat, and aggravate asthma and bronchitis. The third major air pollutant is sulfur dioxide and sulfuric acid. So about 1/3 of sulfur dioxide is put into the atmosphere through the natural sulfur cycle. And the other 2/3 of it comes from human sources, mostly from combustion of sulfur containing coal in industrial plants, oil refining, and from smelting sulfide ores. Sulfur dioxide can be converted to aerosols in our atmosphere, which contain sulfuric acid and sulfate salts. And these chemicals all reduce visibility and aggravate breathing problems. The next major air pollutant is particulates, which are suspended particle matter, SPM. They consist of a variety of solid particles and liquid droplets that can remain suspended in the air for long periods of time. 62% comes from natural sources, dust, wildfire, sea salts. And then 38% comes from burning coal in industrial plants, motor vehicles, and road construction. These particulates can shorten lifespans because there are certain toxic particulates like cadmium and polychlorinated biphenyls, which can cause genetic mutations and cancer. The next major air pollutant is ozone, which is a major ingredient of photochemical smog and can cause breathing problems and aggravate heart and lung diseases. Evidence is showing that human activities are reducing the amount of beneficial ozone and increasing the amount of harmful ozone. The beneficial ozone would be the ozone that is protecting us from the sun's harmful UV rays. Okay, the last major air pollutant is volatile organic compounds. So volatile organic compounds, or VOCs, are organic compounds that exist as compounds in the atmosphere, or they can be gases that evaporate from sources on the Earth into the atmosphere. An example of a VOC would be hydrocarbons emitted by leaves of many plants, and also methane, which is a greenhouse gas that is 25 times more effective at warming the Earth than carbon dioxide is. Methane comes from plants, wetlands, termites, as well as landfills, pipelines, and cows. Other volatile organic compounds are liquids that can evaporate into the atmosphere, such as benzene and other industrial solvents. The case study for 18-2 is about lead poisoning. Lead is a pollutant that can be found in air, water, soil, plants, and animals. And an effect of lead poisoning would be harm to the nervous system, and lead poisoning is especially prevalent in young children. The World Health Organization estimates that 130 million to 200 million children are at risk of lead poisoning. 15 million to 18 million children suffer permanent brain damage as a result of lead poisoning. So, as mentioned earlier, burning coal produces industrial smog. And industrial smog affected many, many cities 60 years ago because of the prevalence of burning coal in these cities. And the industrial smog in these cities was an unhealthy mix of sulfur dioxide, droplets of sulfuric acid, and other suspended particles. So this remains a problem in China, India, Ukraine, and other Eastern European countries. China has some of the highest levels of industrial smog, and it has been reported to have killed 1.2 million people. So photochemical smog is a mixture of primary and secondary pollutants. And the development of photochemical smog begins with exhaust from traffic, which then releases nitric oxide and volatile organic compounds. And in turn, the nitric oxide is then converted to nitrogen dioxide, which will then react with the volatile organic compounds. The resulting photochemical smog is a mixture of ozone, nitric acid, and other secondary pollutants. So photochemical smog is much more common in cities with a sunny, warm, and dry climate, such as Los Angeles, California, and Salt Lake. Process called temperature inversion. And this occurs when a layer of dense cool air is trapped under a layer of less dense warmer air. And this prevents air currents from developing, and air pollution is trapped in the layer. In the trapped layer, may build up to harmful concentrations. Temperature inversions are common in towns that are in a valley surrounded by mountains that have cold weather during part of the year, and also in cities with many motor vehicles and a sunny climate with mountains on 3 sides and an ocean on the 4th side. And an example of that type of city would be Los Angeles, California.
18.3 is on what is acid deposition and why is it a problem. This originates from tall smokestacks, which reduce local pollution but increase regional. And this is due to the spread with more winds, and these can get up to 1,000 kilometers away. Pollutants they spread are usually sulfuric acid, nitric acid vapor, and particles of acid-forming sulfate and other things like salt. This leads to acid deposition, which is sometimes called acid rain. This can be wet or dry. Wet is in the form of acid rain, and dry is more in a form of particles. Acid rain can at times buffer with bases, and it is usually worse in the east and west due to winds. Asia has the worst conditions due to so much emissions and few regulations. This is seen mostly in China. Damages to this can be seen in statues and also the accumulation on tissues. This can harm water ecosystems like fish and surrounding areas. Plants also tend to grow less on these areas affected as the soil is contaminated. The U.S. has since then passed the Clean Air Act, which reduces and reductions of 69% for sulfur and 52% pollution for nitrogen. And acid deposition has solutions with prevention by reducing coal use or burning only low sulfur coal, using natural gas and renewable energy, removing SO2 and NO compounds from smokestack gases, and tax SO2 emissions. Cleanup for this can be adding lime to neutralize acidified lakes, add phosphate to fertilizer to neutralize lakes, and add lime to neutralize acidified soils. And that's it. Section 18.4 is on what are major indoor air pollution problems. Examples of this are particulates, which are pollen and dust, tetrachloroethylene, which are dry clean fluids, tobacco smoke, which is tobacco smoke. Pollution in household areas have 11 common ones, which are 2 to 5 higher than outdoors, and at times it can be 100 times stronger. Animals also produce these with like dust mites, fungus, and molds, which can be seen in like plants. This also leads to health problems like sicknesses, like asthma, allergic reactions, and even cancer in rare cases. Case study for this section was radon gas, which is a colorless and odorless gas and is radioactive. In some homes, it can seep through broken slabs of stone underneath. If it's not fixed, it can harm people, lead to cancer. If fixed, it values up the price of a home, and it costs little or nothing, about $20 to $30 to do a test for radon. And that's it.
What are the health effects of air pollution? Your body's natural defenses against air pollution can be overwhelmed. The respiratory system protects against air pollution in various ways. Hair in the nose filters large particles. Mucus along the upper respiratory tract captures smaller particles. However, prolonged contact with air pollution can overload your defenses. Ultrafine particles can get stuck in the lungs, which can lead to lung cancer, asthma, heart attacks, and strokes. 7% of the U.S. has asthma. 14 people die from asthma every day. Air pollution is a big killer. 3.2 million people die each year from air pollution. 2/3 of those deaths occur in China. 1.2 million people die in China every year from air pollution. 620,000 in India. In the U.S., 150,000 to 350,000 people die from air pollution every year. Prolonged exposure to these emissions can cause cancer. How should we deal with air pollution? Laws and regulations can reduce outdoor air pollution. The U.S. Congress passed the Clean Air Acts in 1970, 77, and 1990. These laws established air pollution regulations. The EPA established air quality standards for 6 outdoor pollutants, which are carbon monoxide, nitrogen dioxide, sulfur dioxide, suspended particle matter, ozone, and lead. The TRA law requires 20,000 refineries, power plants, chemical manufacturers, and factories to report their releases. Pollution created by these 6 major pollutants dropped by 63% between 1980 and 2010. But still, the EPA warns of projected atmosphere warming. The government prepared a rule in 2012 that would require coal power plants to keep their CO2 emissions below a certain level. These plants are responsible for 40% of all carbon emissions. These regulations could reduce 2,000 deaths every year. In 2013, the EPA proposed stricter motor regulations, which would reduce motor emissions by 80%. Environmentalists think U.S. air pollution laws can be strengthened. There are many ways to reduce outdoor air pollution. Ways to prevent stationary source pollution is to burn low sulfur coal or to remove sulfur from coal. One way to prevent dispersal is to remove pollutants from smokestack gases. To prevent motor vehicle air pollution, one can walk or ride their bike. To reduce motor vehicle air pollution, emission control devices could be required. To prevent indoor air pollution, indoor smoking can be banned, and more air can be circulated more frequently. Reducing indoor air pollution should be a priority. There has been little effort to reduce indoor air pollution. Indoor air pollution can be a result of inefficient stoves or open fires. More people could use inexpensive clay or metal stoves, which would also reduce deforestation. We can emphasize pollution prevention. Environmentalists put a lot of emphasis on preventing air pollution. This approach would ask the question, what can we do to avoid producing pollution, instead of what do we do about air pollution?
Hey, Vsauce, Robert here. Good old breathing, the essence of life itself. Well, you'd better breathe while the air lasts, because according to leading scientists, it won't last long. In 1930, scientists developed the first chlorofluorocarbon, or CFC, which developed into a great family of household chemicals that we all use, like Freon, the chemical that makes cold air cold. And while these are great chemicals, it turns out that they have devastating effects on the environment. According to leading scientists, these chemicals leak into the ozone layer and destroy the very thing that prevents us from becoming toast. When the ozone layer in the atmosphere is depleted little by little every year, we draw closer to turning ourselves, and the tiny plankton that we depend on for air,
into charcoal. But there is hope, however, as people from 36 countries met up in Montreal in 1987 to pledge to cut back their usage of CFCs. And it worked for the most part, with most of those countries actually cutting back their CFC usage. But the problem doesn't end here, sadly, as more and more people are using products that use hydrofluorocarbons instead of chlorofluorocarbons. And it turns out that these hydrofluorocarbons are thousands of times as devastating on our atmosphere than chlorofluorocarbons. And countries are now only beginning to cooperate on the removal of CFCs and HFCs. However, they should continue to work together if they don't want to see themselves and their citizens turned into living stakes. And as always, thanks for watching.